All right, guys. So today would be it's quite late. I was supposed to, do this live stream a while ago, but due to a couple of challenges here and there, I had to, take a pause and, you know, do it right now. So today we'll be walking through, what I would say is easily one of the most insane, high stakes system programming story of the year so far, and it's an interesting, um, you know, article by Jared Sumner, basically named, rewriting Born in Rust. And when I tell you, when I tell you I couldn't put this article down, I mean it, right? I've got notes that I took from, this article and all, right? And we are going to dissect, the entire thing as, I proceed in this live stream. By the way, guys, help me retweet. You can also, leave a chat in the comments and tell me what you think. So this particular live stream is for anyone, right? If you're a system developer, you are someone that is skeptical about AI, or you're just someone who likes, absolute chaos, right? Just buckle up, because you're going to get a lot of it from this particular live stream. So first off, let's address the obvious elephant in the room, right? Right at the top of this article, Jared already goes ahead to put out a disclosure that Bond was acquired by Anthropic last year. Was it last year? Yeah, last year 2025, right? Um, so since he's working there now, he got early access to the pre-release version of Claude 5, the actual Claude 5. So that's basically the engine behind this entire rewrite. But to understand, to really understand why, they had to, rewrite, Born, we have to, appreciate where, where Born is, where Born is coming from. That's the origin. So the origin of Born, it's basically a line for line port of the ES build transpiler, which they ported from Go to Zig. According to the article, Jared says, he wrote his first line of Zig in April 2021 years ago. This was, the pre-AI era, right? So the scope here is that Born as a software is a transpiler, it's a bundler, it's a package manager, it's a test runner, it's a HTTP client, and it has a massive chunk of Node.js APIs integrated into it. And the amazing thing here, or the thing to be amazed about, is that one guy wrote all this by himself, you know, in 1 year, and this was during the pre LLM era, right? He wrote it in Zig. So basically, in this article, Jared goes ahead to, of course, give Zig its flowers, right? Um, and we'll be doing the same here because I mean, without Zig, Born would have never been possible, right? Zig actually got Born to over 22 million, active downloads a month. You know, it became, the infrastructure that, Cloud Code, which a lot of people use, was practically run on, as well as Vessel, Railway, Digital Ocean, and the likes, right? But then at some point, they hit a ceiling. They hit a ceiling, and that's the basically the pain that they had to go through. So if you look at my screen, you see a list of bugs, right? You see a list of bugs that was what was common for Born version 1.3.4, as you can see here, right? And if we read through the bugs here, um, you know, you would see that these are low level, bugs. If you've written any low level code, you would recognize some of these things. So you see that we have heap, use after free crash in the node zlib. We have another use after free. Um, we have another, use after free in, the node HTTP 2, right? We have another one in the UDP socket send, right? We have all these bugs and all, right. Then we have like memory leaks. We have like a memory leak in, crypto.script, and we have a double free in, the CSS. I think we have a double free in the CSS parser. Yeah, we have these two. So we have like memory leaks, memory leaks, memory leaks. Um, you know, we have use after freeze, right? Keep out of bound, in UDP socket, crash and out of bound in, buffer and all that. So, like I said, if you've written low level code, most of these, would be things that, would be familiar to you, because every single one of them, every single one of these bugs that he listed here, they are related to, memory safety issues. And that's basically the issue, the interesting thing here. Now, one thing that really stood out for me was the fact that the team behind Born, they were not lazy, right? And these guys, they are absolutely, commendable for, how and the way they managed, teams with Born. And they weren't, they were not being lazy, right? They had, address sanitizers. That's what we call, Asan on every commit, right? They, they had, safety checking, safety checking, you know, with every build, every build or every release build, right? And they were running 247, fuzzing, right? With Fusely, they were doing that. They were doing all these things, right? But it wasn't enough, right? It was not enough, right? Now you would ask, what is the core problem? Well, the core problem is, it's not a zig problem basically, right? If you take your time to go through this, I'm basically just, trying to, um summarize everything and all. But the core issue wasn't the fact that it's a zig problem. The core issue was the fact that it's a garbage collector to native boundary problem, right? So Born, in of itself, mixes, Safari's JavaScript core. So the Safari's JavaScript core, just like we have, I've forgotten just like the way we have, is it V8 that Chrome uses? I think Mozilla uses FireMonkey or something like that. I've forgotten. Um, but in this case, Born uses, Safari's JavaScript core, which of course, is garbage collected, right? With, a manual memory management side, right? So which is the Zig side of things. So you have two completely different memory philosophies, fighting for survival in the same, address space. So if you're familiar with Zig, you know that, you with Zig you rely, on using the defer keyword to manually clean up, memory. You clean up memory explicitly. But the issue with this is that at every point in time you have to remember to, write it at every single, return path, right? If you miss one, you have a leak, right? If you double call it, your program could, possibly crash, right? So now, in the case of Rust, one will be wondering, okay, so why was Rust chosen? In the case of Rust, Rust solves this problem with, the drop keyword. If you are familiar with Rust, there's something we call the drop trait. So that's basically how Rust, solves this problem. So basically, you know, you don't have to define how, memory is being managed, because, Rust, helps you. It automatically cleans itself up, once it's done. The compiler basically does that for you, right? It's a whole complex process that I do not want to really go into, but it does this in, exact, like, in milliseconds, right? It does this in milliseconds. The moment a variable, gets out of scope and all. So for a project where, a project that is breaching, a, garbage collector boundary, you know with, a normal, a place where you handle memory manually, that compiler guarantee that Rust give you, is practically a life, it's basically a lifesaver. I mean, you can really, dive deep into this and read a lot of things. He even goes ahead to, it's a very amazing article. He goes ahead to, you know give examples with codes and everything, right? Talks about, you know why they chose Rust, which is something I've mentioned. I talked about the drop, keyword. I go ahead to talk about, how it automatically handles, the cleaning for you, where you do not have to, think about how you're going to, handle it manually yourself. So there's a whole lot here for you to, to really dive deep into. These are very important, sorry, very interesting concepts. I'm sure I found it very interesting when I was reading it. You can also, you would also find it very interesting, understanding why, how Rust solves, you know, a whole list of memory issues, bugs that comes with memory issues. The reason I love Rust, right? It takes care of, the use after free bugs, double free, forget to free in error paths and all that. Like, so most of the, issues that you would face, that relates to memory, the memory, like memory management and all that. Rust automatically solves that for you. Unlike, with languages like C, C++, or Z, where you have to manually clean up, after yourself. But then, right, this is not like a Rust centric video, though, yeah, it was, Zig was Bun was written from Zig to Rust. But then, there is the part where, is also very interesting, right? How Jared, I call this part basically, the hustle, right? How he was able to, rewrite, Bun in Rust in 11 days using, 64 Claude instances, if I'm correct. And for me, I consider it like an absolute chaos, right? But made a lot of sense, and it's very interesting, which is something that, I would be summarizing. But basically, historically, Bond has about 500 and 35. Let's just call it 500, over 500,000 lines of, code, right? Of Zig code, right? You know, now for a startup, right, doing a rewrite of over 500,000 lines of code would be the absolute death for any startup, right? Because what happens at that point is, you know, it will freeze future releases, it will stall bug fixes, and it will take the team a year and right to do the complete rewrite plus testing and all that, right? Now, this is not something that most teams will want to do. So Jared on himself, in himself, like Jared, what Jared, the smart thing Jared did was, you know, to play around with I'll call it like a wild hypothesis, right? Which is basically saying, okay, can Claude do this for us? Um, you know, and that's basically what what this entire, like, for the most part of this article, what is it's about, right? And during the course of my reading this article, I got to understand now within days a massive chunk of their TypeScript based test suite, we're already passing, right? And with that result that he got, he decided to go all in, you know, with with a mechanical, 5 for 5 port, something like that, without trying to over engineer things, right? So basically saying, make the Rust look like the zip code, so that it will be easy for them to refactor later on. So now, the interesting thing to talk about here is the orchestration, right? How did they, orchestrate this, right? So basically, he spun up about, I think, 64 parallel instances of Cloud code, which were running, across, 4 local work streams, right? And this is, for me, where the real engineering goal is, right? It's basically something he called the, I think, the adversarial pattern, right? So I'll just basically search um, through the article. So basically, it's the adversarial, yeah, exactly. So the adversarial review pattern, right? And basically, what this is that for every single file, right? For every single file that is ported, so you have one Cloud code instance that will write the code, right? To write the code from Zig Rust, right? Then you have two separate clouds in isolated window context or context windows whose job is basically to find bugs to review, right? the the most important and differentiating thing about them is they couldn't see like the builder's reasoning, right? So the guy that was responsible for like rewriting the Z code to Rust was on a separate context, on a separate window, right? The guys that were responsible for reviewing the code, right? They were explicitly told to assume that the code was broken. So, and they were explicitly told to assume that the code that they were reviewing was broken, and their task was to find bugs in that code, right? So the important takeaway here is that this split incentive was genius, right? It's like for me, it's like the most amazing thing about the whole write, right? Um, because why it's amazing is because the cloud that is writing the code wants it to pass. So it wants it to, to ship. While the reviewer, who has been told to break things, wants to break things. So at the end of the day, you know, at least to a great extent, they are not stepping on each other's feet. And doing this, according to the article, caught some interesting bugs in the libuv. I think one of them was an asynchronous lifetime mismatch in libuv, where a pointer was being passed to a C callback, but the underlining rust, which is underlining rust pointer, which like the box was dropping immediately at the end of the scope. So the reviewers, the two Claude reviewers, they caught it, right? They caught it, and ideally, if they had not caught it, that would go ahead to be a use after free, you know, a use after free bug, right? Right, something like that. So they flagged it, from the difference alone, right? So it's very interesting, if you dive into it and try to read how they were able to how Jared was able to set up this this particular cloud orchestration, like I can call it that, right? Now, of course, with everything like this, there would always be issues, right? There will always be you know problems and all, right? And some of the problems that came up, or that emanated from the setup was one, there were issues with git stash. And what that meant is, early on, the parallel agents, they started to like step on on each other's toes. So one will get starch and the other one will get reset head, right? And at the end of the day, they will end up overwriting or destroying each other's work. You know, so according to Jared, he said he had to ban them from touching Git entirely. Right, that was his solution for that. The second one was, when the I think he called that the stubborn trick or something like that. When when basically when you're trying to fix a lot of compile error, like he was trying to fix about, I think, 16,000 compile error. So at some point, Claude got lazy and he started stubbing out broken functions or writing out long paragraphs of comments, to try and justify why it came up with a hacky workaround, you know so Jared basically had to set a hard rule where he said if you needed to write a paragraph of text to justify your code, then that code is probably wrong, right? So you just go ahead and fix it, right? So that was what stopped that particular issue. Then there's the aspect of the infrastructure meltdown. So basically, Bond's test suite is incredibly aggressive, right? According to the article, they have test suite for OS limits. You know, they have test suite for spanning over 10,000 processes, flooding network sockets, reading gigabytes of digs. So due to this test suite, the host machine kept on crashing, right? So what he did was he had to isolate the agents. You know, he had to isolate the agents test, and sorry, he had to isolate the agents and run the test using system ng dash run. And what that did was basically creating there are dedicated, C groups, for them, you know. But at the end of everything, the momentum wasn't, was unstoppable, right? Because they went from, day one, 900 and I think about 972 tests failing on day one to about, 23 on day three, and they had a fully green test suit on day four, right? And this, built across, I think 542,000. Yeah, I think this was something that built across, I think, across Mac, Windows, Linux, and the rest of them, right? So basically, according to the article, at the peak of, you know, at the peak of at the peak of this whole process, you know, Claude code was churning out about 1,300 lines of code per minute and over 695 commits per hour. It's crazy, right? This is like it's crazy work, right? So according to Jared, or according to the article, the final bill of the token was about $165,000 in API credits, right? So it's really amazing. It's an interesting read. It's something I would implore anyone to go ahead and read. Myself, I did a lot of deep dive into the Rust specific aspects. Really understand, like, to really dive deep and understand why Rust was picked over Zig, the problems it solved, which these are stuff that I talk about in my videos from time to time. How Rust helps to solve memory issues using the ownership model, issues like double freeze, use after freeze, stuff like that, like memory leaks and the rest of them, because Rust takes them from being a runtime error to something that you have to deal at compile time, right? And due to the fact that you cannot handle memory manually, so there will never be a case where you say, okay, I forgot to handle memory here, or I freed memory twice, right? Leading to double free. Was it worth it? Well, for me, in my opinion, right, looking at the numbers, right, so they went from having over 6.7 gig leaks in the previous zip code to a flat out 609 megabytes like in Rust. I would say that's like that's a great improvement. The binary size also dropped by 20%, became 20% smaller. The parser stack space, which usually crashed at very deep levels, with Rust, it could handle up to 25,000 levels deep, right? So there was, in my opinion, I would say it's worth it based on what Jared has disclosed in the article. And it didn't end there, right? He even went ahead to mention that they even uncovered bugs that had been hiding in the zip code for years. For instance, he said, the article said that there was a silent off by one bounds error in the module resolver, right? Something like that, which was writing past the arrays. And so he said a lot of things about how this how Zig was the cause for that and all. But I'm not really familiar with Zig, so I did not really go deep into it. But that particular bug in Zig, the end the end point of it is that that particular bug in Zig silently corrupted memory, right? But due to Rust's default check, it immediately caught that, and it panicked, right? Thereby, um, you know, preventing that bug. So now, in a nutshell, right? For me, the takeaway here, and I mean, I've really glossed over, you know, the I've really glossed over the article because I do not really like the article is amazing, right? It's something I believe everyone should read. It's amazing, right? um if you're interested in like Rust, there is the Rust side of it. If you're interested in Zig, there is the Zig side of it. If you're interested in writing loops, right? Orchestrating the adversarial pattern that Jared used in his article. It's also amazing because of the way he did it, right? um Basically setting up one Claude instance, in the simplest form, right? One Claude instance that converts that rewrites the zip code to Rust code and tries to match it exactly the same way. Then two reviewers that is asked to absolutely look for bugs, right, in the code. In fact, it's asked to just assume that that code is buggy, right? So it should be brutal with it, right? And the final one that um yeah, and the final one, right? So the point here, or like the point of the takeaway, sorry, in this is that, or I would say what you could learn from this article is one, trust ownership model is king when you're working on like sort of like hybrid system, right? You're working on a hybrid system. The trust ownership model is king. And what I mean by this is if you're bridging manual memory with a garbage collector. So like for instance, what this means is Bun uses JavaScript core, which is from Safari, which is uses JavaScript core, which is which is garbage collected, right? Then it handles memory manually using Zig's defer keyword. Right? So there is a bridge between manual memory management and a garbage collector, right? So you would always have memory issues in that situation. So when you find yourself working on something like this, then you know that this is the right time for you to employ something like Rust, right? Because now Rust now uses the drop traits to automatically handle this for you, because compiler guarantees that you know this is not something that will get into runtime, right? So it is essential for your sanity. This is not even about Rust being an amazing language, right? This is about your sanity, just like how Jared has shared in in his article. Now, then there's the aspect of if we are being sincere, right? Any of this would have not been possible if you know they didn't have like very robust test suits, because according to the article, and I absolutely agree with this particular rewrite would have not been possible, or it would have not succeeded, um, you know, without those test suits, right? Um, because yeah, LLMs are good, right? But then at the end of the day, the TypeScript test suits, were something that was made language agnostic. So the agent is basically, in this case, the eyes, the hand, while the test suite is the eyes that tells you that okay, this thing that I'm actually rewriting from Zig to Rust, actually makes sense, right? It passes, right? It's something I can trust, and maybe merge to master or like Jared did. Then there is the AI, the AI paradigm shift, which I had mentioned initially, right? The real breakthrough here, isn't the fact that he just went ahead and said, Claude, pretend that you are a senior software engineer, rewrite the entire Born code base to from Zig to Rust. It's the agentic system design, right? The adversarial review loop, that he did, where he split the context, and sharded the environment, right? That's basically how Jared, which is one engineer, did a year worth of work in 11 days. Like I said, this is a very, very, very interesting article to read. I read it. In fact, I've not even done enough justice to this article in my explanation, because I do not really want to go very, very deep into a lot of things. I have a lot of things I could, you know, continue talking about. But if we do that, you know, this live stream is not going to come to an end, right? I will implore you to, take out your own time, try to read it for yourself. Let me know what you think, and I'll see you guys in the next one. Peace.